Hello and a very warm welcome here from the virtual studio of the 5G Alliance for Connected Industries and Automation. My name is Andreas Müller. I'm the General Chair of 5G ACIA, while in my day job I'm coordinating the industrial 5G activities within the Bosch Group. In order to give you a little bit an idea about where we currently are on the industrial 5G journey, some 5G ACIA members have prepared a couple of exciting and insightful video demonstrations which we will present to you in this and 5 similar sessions throughout this virtual fair. In the following, the main focus is on some important aspects, such as the role that eSIMs will play for providing highest levels of security in future, why edge computing matters in this context as well, and also how network slicing can help support industrial 5G systems. First of all, however, it's a great pleasure to announce a joint contribution by Nxp Semiconductors and HMS Industrial Networks, who will show us some recent trends in industrial 5G, including the integration of 5G with Profinet, Open RAN, as well as some pioneering applications. So really interesting stuff. Let's check this out.
Are you ready for the next industrial revolution? Industrial 5G will change the way we make decisions, manufacture products, and maintain factories. In fact, it'll change the world. But what does that actually mean? What are the immediate benefits of 5G communication in a factory?
With 5G in factories, users will benefit from a robust wireless network, which will meet the industrial demands in terms of communication speed, real-time and security. All very important in industrial applications where downtime and failure is not an option. All of this in combination with the flexibility and mobility that comes with wireless.
And 5G is not a future technology, it's already here. Let's have a look at a real-life demo using 5G components from HMS and Nxp. The user equipment in this demo is the Wireless Bridge 5G from HMS, based on Nxp's IMX applications processor technology. It is an Ethernet to 5G communication bridge that enables industrial machines or control systems to connect to a 5G network. The Radio Access Network, or RAN, is powered by the Nxp LX2160A layer escape processor, which has the processing power and flexibility to run the Open RAN architecture, either as a 5G distributed unit or a centralized unit. In this demo, a distance sensor changes its state depending on the position of an object in the detection area. The sensor output is formatted as a secure OPC UA message and published to the server. Then these messages are transmitted via the HMS wireless bridge to the 5G small cell, where the baseband unit processes the data at layer 2 and 3. At the other end, the OPC UA client connects to the 5G core network using the N6 5G interface and receives the message to report when the distance sensor detects any movement. It's also possible to use Profinet over the 5G cell. To do so, a tunneling protocol is required to send traffic through the IP connection on the 5G network. 5G can also work with TSN Ethernet, providing similar time shaping and preemption capabilities.
The rollout of 5G has already started in small scale with test installations and proof of concepts. But as 5G and also the industrial use cases continue to develop, we will see a gradual rollout over the coming next years. But also, based on the values that 5G and wireless brings, we will most likely see a faster rollout compared to other communication technologies historically in the industry.
We have seen the first demonstrators, but there is 3 big vectors that we now need to drive, of course. Firstly, system cost. So it cannot be the task only to shrink big base stations and try to fit them somewhere into industrial footprints. We need to rethink system setups to make them attractive, also cost-wise attractive for small, medium enterprises. Secondly, we need, of course, to have an ecosystem support, not only for installed big industrial equipment, but also for a variety of other participants, mobile robots, edge type of devices that are showing up in that communication ecosystem. And thirdly, privacy and security needs to be, of course, ruggedized and optimized. We, of course, need to make sure that this is all industrialization rollout ready, mass volume ready.
As these factors are coming into place, more and more industrial environments are looking into implementing 5G. But who will be first? Where do we see the early adopters?
Well, applications where the technology brings direct and clear values, like in industries with high flexibility demands, such in automotive, or in applications with challenging use cases, like in AGVs, material handling and mobile machines, all supported by the Industry 4.0 vision.
The semiconductor players, we are very active in this ecosystem. We are, of course, engaging also very closely in standardization activities and consortia like ORAN, 5G, ACIA, and others in that area. And of course, I'm particularly proud to have HMS here helping us driving the next steps in this ecosystem.
Great, many thanks again to NXP and HMS for this excellent contribution, and I'm already looking forward to see what they will come up with next. The next contribution in this session, however, is from Infineon, another very well-known player in the industry, of course, and also a valued 5G ACIA member. And here we will start with a short teaser video. So let's have a look. And now it's a great pleasure to welcome Lars Wemme here in our virtual studio, who is the Vice President for IoT Security at Infineon Technologies. So welcome, Lars. Thanks for taking your time and for being with us today.
Thank you very much for having me, Andreas.
So Lars, 5G is sometimes promoted as the network of all networks. Will it live up to its promise, or is it all just a hype?
The deployment of 5G and the move towards cloud and virtualization are reshaping operations and practices across industry. Analysts predict impressive growth for communication devices and machines using 5G network. The transition is being rolled out with the purpose of having faster and more reliable cellular communication combined with the capability to also connect network-constrained devices on a public or private network. If we take the example of a manufacturing plant, this 5G network of networks will enable the connection or interconnection of battery-operated smart sensors, mission-critical edge devices, routers, automated guided vehicles, and cloud servers. The deployment of such a broad variety of things is attributable to new 5G features such as multi-network slicing and multi-connectivity networks. It's now clear that 5G technology supports billion of devices and meets industry's most pressing demands. Scalability, ease of deployment and wide coverage, cost and energy consumption efficiency, data capacity and transmission speeds. But by delivering the required agility and economies of scale, 5G is also significantly changing the attack surface for attackers as the number and diversity of connected things rises at speed.
So that brings us on to the topic of security, which is always very important, of course, particularly in the manufacturing industry. What are the special threats that 5G has to face, and how can we deal with them?
This new and broader attack surface greatly increases the scope of potential threats relative to the risks that preceding 2G, 3G, and 4G generations faced. This includes the risk of data manipulation, denial of service, device tracking, spoofing, eavesdropping, and piracy. In other words, an attacker may prevent a user from entering a building or could expose or manipulate confidential or mission-critical data while it's being transferred to the cloud. The more complex the device, the greater the risk of attack, but also simple devices such as coffee machines or smart light bulbs serve as an entry point for attackers. This means that a high level of security is necessary across the board and irrespective of each connected device resources. The good news is 5G now incorporates the security controls required to address those threats. 5G has the security capabilities to protect subscribers, devices, and their communication, but also the integrity of the network itself. Security can be achieved through mutual authentication of devices and of the network, as well as through the encryption and signing of data traffic.
Yeah, great. Thanks, Lars. That's very interesting and insightful. I'm just wondering, what role does the SIM play in all of this?
The role of the SIM is to establish a link between the final user or device and the mobile network operator, and in the end to enable the connection to the cellular network. The SIM stores credentials such as network keys and unique numbers to identify and authenticate the device that consumes the data. The SIM is based on proven technology and has been successfully deployed for many decades now. Comprehensive standardization provides interoperability between the various providers and operators across regions.
So how do 5G SIMs and eSIMs in particular contribute to security?
SIMs have evolved in the same way as core network architectures to meet evolving security challenges. Thanks to its new architecture, algorithms, authentication policies, and protocols, 5G SIMs play a pivotal role in meeting the high security standards required across all device types. Regardless of whether a device connects to the network continuously to exchange gigabytes of data, or it connects only from time to time in order to exchange a few bytes, 5G SIMs provide the required level of security. For devices that have a projected lifespan of 15 years, over-the-air provisioning and firmware patching are additional key capabilities. Modern SIM implementations use powerful 32-bit security processing cores along with hardware crypto accelerators and protected memories required for 5G security algorithms and secured storage of encryption keys. Additionally, they integrate advanced power-saving modes for battery-operated devices and a wide range of security features such as shields, fault detectors, and countermeasures. Compared with a removable SIM, the embedded SIM, which supports remote provisioning, is actually the more secure option for new IoT and M2M designs. The GSMA requirement for embedded SIMs also go further than those that apply for the removable SIM, covering testing and certification of the product itself, but also audits of supply chain and manufacturing processes by independent certified laboratories. Infineon meets the growing need for trust in 5G networks by offering a broad range of security controllers and Optiga Connect turnkey eSIM solutions. These solutions outperform GSMA security requirements and are certified according to the International Common Criteria standards. At their core is a security controller providing the robust and trustworthy vault required to protect against fraudulent use and to store sensitive keys.
Great. Thank you very much indeed, Lars, for these very interesting insights and for being with us today. That's very much appreciated.
Thanks a lot for the invitation, Andreas. It's been a pleasure.
So now we move on to the next contribution, which has been prepared by AI-Link from China, and they're especially considering the combination of 5G with edge computing and artificial intelligence, which makes industrial 5G even stronger. And also here we start with a short video first.
Towards an Industry 4.0 future with 5G, it is necessary to provide one-stop 5G plus edge services to support flexible and intelligent manufacturing with digital network transformation at the factory floor level. A blend of terminals, 5G network components, edge cloud platform and industrial applications is needed to deliver a last-mile solution for building up the right 5G plus edge cloud ecosystem. Further, customized private 5G deployment with real-time monitoring of industrial APP health levels, adjustment of 5G uplink and downlink ratios, and guaranteed QoS for different data traffic flows are required for such deployment. In addition, ultra-lean management of private 5G plus edge network, AI analysis of network quality, real-time end-to-end status monitoring, and visualized management of edge cloud IT infrastructure are all essential to help enterprises be in total control of their IIoT operations. With the above in mind, AI Link was born. It pioneers 5G plus edge deployment in the building materials industry. A one-stop solution is provided for the circular production lines of a large precast cement production plant, which realizes IIoT use cases such as auto transportation by cloud AMRs, real-time positioning of kiln cars, production site safety detection, and quality inspections through the provision of uplink-intensive transmission over private 5G and machine vision acceleration over the Edge APOS platform. AI Link, the industrial 5G plus edge service provider.
And now it's my pleasure to welcome Lee Rong in our virtual studio here, who is the Chief Marketing Officer of AI Link. Lee, a recent study by Frost & Sullivan indicates that 90% of all industrial enterprises will start using edge computing by 2022, by the end of next year. How do you see this development and its relation to 5G?
Thanks, Andreas. Yeah, so exactly, we do see more 5G networks being deployed in factory environments. And with scale coming up, we will see more devices connected and in the factories, as well as more data procured through those connectivities, together with more varieties of 5G-based use cases running on top. And this will require a future private cloud platform running at factory level to host all these new use cases and the data. And hence, that's why we see 5G is going to be one way to accelerate edge computing deployment in factories. AI Link is aiming to provide such a 5G plus edge solution to exactly do, to release the power of industrial IoT towards Industry 4.0.
Yeah, thank you very much, Lee. So if you look at the combination of 5G and edge computing, we basically see two major trends. Number one, a rather lightweight solution on site in a factory with a private 5G deployment. And number two, a more heavyweight approach based on existing assets, primarily of mobile network operators with hybrid 5G deployments. Which approach do you see as the more suitable one for the factories of the future?
Yes, and we do see there are two different trends moving forward. One is backed by public operators based on their existing assets and defined by ETSI on the NEC solution for factories. But there's one problem with such a solution is that usually it's not deployed in factory compounds and hence it has a security issue. Second, ETSI NEC is not designed from the very beginning for Industry 4.0 and it's lacking these specific features. On the other hand, as AI Link, we are aiming to provide a private 5G edge computing platform from the very beginning with Industry 4.0 in mind. And we are designing PaaS layer features that leverage 5G functions and together with easy to build and program Lego style modules aiming to provide this relevant functionalities to the industrial applications on above, such as OPC UA, such as TSN, etc.
Great, thanks. I'm afraid we are running out of time and have to move on to the last demonstration in the session here. So thank you very much again, Lee, for being with us today. And last but not least, we have an hour short contribution by Druid Software on the European 5G Encode project, Druid Software is one of the latest 5G ACIA members, and they have jointly prepared this contribution together with Airspan, Zeetta Networks, and Telefonica. So let's have a look.
Welcome to 5G Encode. Run by a consortium of industry leaders and led by Zeetta Networks, the project will develop clear business cases and value propositions for 5G in manufacturing. The project will explore 3 5G use cases: augmented and virtual reality for industrial applications, monitoring and tracking of time-sensitive assets, and wireless in-process monitoring and analytics. Using augmented and virtual reality to support design, manufacturing and training will dramatically improve efficiencies and reduce cost. Thanks to 5G's high capacity and wireless nature, sensitive assets can be tracked both in factory and in transit in real time, improving productivity and reducing cost. 5G's ultra-reliable, low latency and high bandwidth capabilities make it ideal for in-process monitoring and analytics, boosting output and making machines work more effectively. If you want to find out more about 5G Encode or are interested in getting involved, please get in touch via our website or find us on social.
Excellent. And here next to me, you can see now Vasilis Seferidis, who is the CEO and co-founder of Zeetta Networks. So Vasilis, thanks a lot for the really nice contribution. And unfortunately, we only have time left for one short question. But could you please give us a little bit more insights into this network slicing approach and multi-domain orchestration that you are considering in the 5G Encode project?
A key innovation of the project is the automation of network service orchestration through network slicing and splicing. Network slicing, of course, is the process of defining isolated and virtualized subnetworks, which we call, of course, network slices, from a common physical network. Each slice is defined so it is delivering the service differentiation required to meet the end user requirements in an efficient and economical way. Network splicing, from the other side, is a new concept that we have introduced, which can be considered the opposite of the network slicing, whereby 2 or more subnetwork topologies are merged together to form the aggregate topology of the underlying subnetworks. It is a very useful concept that can be used to simplify and automate the provisioning and management of the end-to-end services across private and public 5G networks. In the case of the 5G Encode project, network slicing and splicing is used to deliver seamless service continuity. And I'll give you an example of how we are going to use it. One of the use cases we have in the 5G Encode project is the asset tracking service, whereby time-critical assets must be monitored both within the factory and while in transit from one production site to another, and as they move from a private 5G network within the factory to a public 5G network provided by a major telco, in this case Telefonica UK. Inside the factory, the private 5G network creates a dedicated slice for the asset tracking service that satisfies the specific requirements in terms of bandwidth and latency. At the same time, a dedicated slice is created by the telco in their own public 5G network with the same bandwidth and latency requirements. Then the 2 slices are joined together, basically spliced, through the network splicing process. The coordinated provisioning and splicing of the 2 network slices are done by Zeetta NetSplicer, a multi-domain orchestrator that produces the aggregate topology of the 2 slices and allows the seamless delivery of the asset tracking service across the private and public networks.
Great, interesting stuff. So many thanks again, Vasilis, for taking your time. And this already concludes our virtual demo session for the time being. If you would like to see more exciting demos of 5G ACIA, don't miss the next virtual demo session, which starts at 6 p.m. Central European Summer Time later today. But I would say thanks for joining us today, and bye for now.